So y equals 3 times sine of 2x. Now I have to remind you of something here once again. Something from that you'd get in a course like college algebra. If you have a function y equals f of x, and you know what its graph looks like, and then you'd like to know what the graph of y equals f of, say, b times x. B is a constant. If you'd like to figure out what the graph of y equals f of b times x looks like based on your graph of y equals f of x, there is a way to do that without plotting points. Because we're multiplying the input coordinate from the original graph, we're multiplying that by b. It's going to affect how stretched out or compressed the graph is horizontally. Because think about it, x affects the horizontal, right? So you multiply by a factor of b, and you will affect the graph one way or the other. It'll be compressed or stretched out. So I have to remind you, my job here is not to derive this for you, but to remind you of how to handle a horizontal stretch or shrink. And the thing to remember is, it's a little, it's kind of reverse of your intuition, but that b, the stretch or shrink factor is 1 over b. So the horizontal stretch, I'll say stretch slash shrink factor is 1 divided by b. And it's this factor that gives us our formula for finding the period. What's the normal period of the sine function? 2 pi. So that's how wide one cycle is, right? Normally, if it's just y equals sine of x, or y equals 2 sine of x. If you're not doing anything to the x, you just have 1 times x as your input, then the width of one cycle is just 2 pi. So what is acting like the thing I'm calling b in this statement? 2. So the stretch or shrink factor, 1 over b, is 1/2 here, 1 over 2. So we're going to get our new period then, we're going to multiply the normal period of the sine function by 1 over b, by 1 over 2. So 1 over 2. And then that's the same as, if you multiply straight across, that's the same as taking 2 pi, the regular period of the sine function, dividing by b, which is 2. Let me do that in purple then, to color code this thing. And so what do you get for your new period? Pi. By the way, what's the amplitude? 3. So it's a good idea to write down if it's not y equals sine of x, if the amplitude is going to be different than that and the period is going to be different than that, it's a good idea to write those things down first. So does that affect how the method that I showed you in the last example for graphing this thing? Not at all. It's still going to be a sine wave. So I'm going to draw the sine wave first and then scale it appropriately based on what we just discovered about the period and the amplitude. So I'm going to start out exactly the same way. I'm going to draw a sine wave. It'll look more or less like the one I drew in the last example. And again, when we're doing this by hand, for the most part, you're just going to graph 1 or 2 periods. I think I can do a little better than that. Or for the most part, actually 1 period, and then maybe 1 or 2 homework problems, you'll have to graph 2 periods. So something like that. So what is that scale mark on the x-axis going to be labeled here? Yeah, the period is pi. Question?
For the quizzes or tests, you have to write all of the points on the x-axis.
Essentially, what we did in this last problem was we plotted these 5 points, right? This point 0, 0. In this problem, it was, well, in every problem it's going to be 0, 0 unless you translate it horizontally. And then we plotted this high point, this x-intercept, this point, this x-intercept. I expect you essentially to plot those 5 points using the method I'm showing you every time. And in fact, that's exactly what I'm going to do right now. I'm going to break up the period into quarters, just like I did in the last one. But now this halfway point will change. What is it going to be? Pi halves. And the x value underneath the maximum value, the maximum height here will change. What's it going to be now? Well, no, if you think about it, it'll be half of pi halves, right? Which is pi fourths. And then this hash mark, which is the 3/4 hash mark, the 3/4 of the way through the period, will be halfway between pi halves and pi over 1, or just pi, 1 pi. So it's got to be 3/4 pi, right? 3 pi over 4. Again, if you need to, you can just average pi halves and pi, and you'll get 3 pi over 4. How high does it get? It does get up to a height of 3. How low does it get? So we essentially plotted these 5 points, 0, 0, pi force 3, right? If you needed to, if you were asked to, you should be able to label the ordered pair. This ordered pair is pi force for the input, 3 for the output, right? But normally it would get messy if you labeled all those ordered pairs, so you just do it with the scale marks. Then we plotted this point, and this point. The same, proportionally the same 5 points as in the last problem, right? It's just they had different inputs that went with them, and a different output for that matter.